Okay, let's look at how we can go about to solve part C. So in this case, we have already discovered in part A that the current is actually 0.5. Okay, that passes through R. And in part B, we already calculated that the current is actually 1 ampere. So with these two information gotten in A and B, we can go about use all this information to solve part C. So how do we go about to solve this? Let us look at the question. What is the potential difference across S? So S is actually here. Okay, this part is actually S. So it's actually looking for the voltage across S. We want to find the voltage across S. There's a formula that says that V is equal to I times R of this 4 ohm. So in this case, I already have my resistance 4. So what I'm lacking is actually my current. But actually, if you look at part B, I already gotten my current, which is actually, I can label this as 1 ampere. So this is actually 1. So my answer for part C will be 4 volts. So this, my answer will be 4 volts. Okay, let us now take a look at how we can go about to solve part D. Part D looks for the potential difference of the battery. In this case, it's actually looking for EMF. Okay, EMF represents the total potential differences of all the individual components that is in series. Okay, so in this case, we look at series, P, Q, S are actually in series. So in this case, we can actually ignore the potential difference across R. Okay, because the potential difference across P and Q is actually the same. So potential EMF is actually equal to my potential difference across P plus my potential difference across Q plus my potential difference across S. Okay, so in this case, let's take a look at how we can find the potential difference of P. When we look carefully at P and S, we realize that this is actually a series connection. So in a series connection, the current is actually the same. So in this case, if this is 1 ampere, the current that flows through P will also be 1 ampere. Okay, so you know that this is 1 ampere, we got the formula V is equal to I times R, which is across P. So the potential difference across P will be 1 times 4. So the answer is 4V. So we can fill in this part as 4. Okay, and we have shown the potential difference across Q. So the same thing, just now we have calculated in part A that the current is 0.5 ampere across R. So it's actually the same across Q. Okay, so this is 0.5. So if the current is 0.5, we have the formula to find the potential difference across Q. So in this case, my V is equal to I times R. I is 0.5. The resistance is 6. So answer is 3. So I fill in this as 3. Potential difference across S, if you look carefully, it has been actually calculated in part C. So I just use my answer in part C, which is 4V. Okay, I just add together. My final answer is 11V. Okay, so this is the answer for part C as well as part D.